Ladies and gentlemen, welcome to section 11.6, Adding and Subtracting Rational Expressions, Part 1. Let's start off with a fraction. This fraction will represent all rational expressions that we are doing today. Remember, when we add fractions, what has to be the same? Well, the denominators, the bottom of the fractions have to be the same, so they are both 5s, correct? So now when we add, we just add across the top. So 2 plus 3 is 5, and that will go over 5. The bottoms will stay the same, and if we wanted to, we could simplify that to 1. So how does this help us with rational expressions when we are asked to find the sum or difference? Well, here are two rational expressions that are being added together. Are the denominators the exact same? Yes, they are. So they are exactly the same. So now I have 15, and that's going to go under what's on top. We have 4b plus 16b. Can we combine like terms? Yes, we can. So that's going to be 20b on top over 15. Can we simplify the numbers like what we did yesterday? So what can I take out? I can divide out a 5 on top and bottom. So we simplify it to be 4b all over 3. Now, ladies and gentlemen, you will find out that you do not have to show this step. I just showed it for the purposes of being the first example, but you do not have to show this step. Let's try number 2. Look at your common denominator. Do we have the same common denominator? 5xy, 5xy? Yes, we do. So you go ahead, put that on the bottom, 5xy. That's going to go underneath. What is on top? 4t plus 7. Now, can I combine these two, ladies and gentlemen? And be very careful, because can I combine a 4t with a 7? I cannot. So my answer is right there, 4t plus 7 all over 5xy. Now, 3's trying to get a little bit tricky because I have y plus 3 and 3 plus y. Can I combine these? Well, what does the bottom of this guy turn into? That can also be written as y plus 3. Yes, I did not change any signs. I just rearranged them. So now we have the same denominator. So let's go ahead and carry that down. Y plus 3. That goes underneath 6y minus 3y. Now they are like terms, so I can combine them to get 3y all over y plus 3 for our final answer. Again, ladies and gentlemen, if you know that these are like terms right away, you do not have to show that step. I did just so you could see it. 4. Now we are going to start to subtract. Ladies and gentlemen, when we subtract, we have to be careful. When we subtract, we again first have to check, do we have the same common denominators? Yes, I do. They are both x minus 3. So I'm going to go ahead and bring that down. I have x minus 3 for my denominator. That's going to go underneath. I'm going to bring down the 7x plus 9. So it's 7x plus 9. Now, ladies and gentlemen, this minus sign changes a couple things. I'm going to go minus, and then I need parenthesis, x minus 5. And you will see in one quick second why I need these parentheses, because what does this negative do here and here? Well, let's continue with this. I have 7x plus 9. All right, now after I distribute that negative, it's going to be a negative x plus 5. And that's still over, though. That's still over x minus 3. Now, if we simplify one more time, what's going to be on top? What are your like terms? 7x minus x gives me a 6x. 9 plus 5 is plus 14. And that's all going to go over x minus 3 for your final answer. Again, with 5, do we have the same common denominator? Yes, we do. So I'm going to bring that denominator down. Again, ladies and gentlemen, we are dealing with subtraction, so be very careful with subtraction. We have 2h plus 4. And now, in parentheses, I'm going to say minus 5 plus h in parentheses. Remember to distribute that negative to everything inside those parentheses. So now I have 2h plus 4, and that's going to be minus 5 minus h. What's that go over? That's going to go over h plus 1. Let's simplify that top to be 2h minus an h is h. 4 minus 5 is minus 1. That all goes over h plus 1 for our final answer. Jumping to 6. Now do we have the same common denominators? It looks close, but what if I rewrite this guy like this? I'm going to move that t in front. Well, that t is what? That t is actually a negative t plus 3. So is this guy the same as that? It is not. So what do we have to do? You can think of it two ways. You can think of pulling out a negative, which I like to do. I'm going to take out this negative and see what happens. So I'm going to take out a negative. I'm going to take out that negative 1. What's left inside negative 1 times negative 1 is positive, and then positive times negative is negative. So it turns into a t minus 3. You can also think of this guy as multiplying by negative 1, and what's it turn into? Turns into this. Now, t minus 3 and t minus 3 are the same thing, right? This negative just goes to the 3. Just goes to the 3. That negative goes right up there. So now, on top of my fraction, I have t squared, and then I have the minus from the negative 1, and then it's going to be minus 3. What's that go over? What was our common denominator? T minus 3 for our answer. 7. Same situation. Check this guy back here. Is it the same as this guy? It is not. I'm going to rearrange it to show you that it's negative 11 plus x. Remember that negative, this negative right here, belongs to the 11. So now what do? I'm going to take out a negative 1. So I take out a negative 1. It's going to be 11, because negative 1 times negative 11 is positive 11. Negative 1 times x is a negative x. So now this and this are the same. I'm going to go ahead and write one common denominator. It's going to be 11 minus x. That all goes over, grab a different color, 3x. Now we have two negatives. Yes, we do, ladies and gentlemen. We have a negative here and a negative there, so it's going to make a positive 5x. And now just combine like terms, so it's 8x over 11 minus x for our solution. Now we're going to get into one vocab word. It is least common multiple. Our least common multiple is the smallest number that is a common multiple between two or more numbers, or just a number that you can multiply to with those numbers. So how do we find the least common multiple for each pair of polynomials? Well, you can go ahead and multiply 12 and 32 together to give you your multiples, but that won't be the least common one. So I'm going to break 12 down into factors, into the smallest factors. So 12 breaks down into 2 times 2 times 3. I'm also going to break down the b's into b times b, and also the c's into 1, 2, 3. There are 3 c's there. Now I'm going to break down the 32 into, well, I know 32 is 2 times 2 times 2 times 2 times 2, 5 2's right there. And then how many b's do I have? I just have 1 b, and I have 2 c's. Now when we do least common multiple, we have to take the numbers that occur the most often. So since I have 5 2's, I'm going to put those 5 2's in a box. I also need a 3 because it's the most 3's that occur. Now you also need to take the most letters that occur. So I have b squared, and I'm also going to take that many c's because 3 c's are more than 2. So now what all did I take? I have 5 2, so it's 2 times 2 times 2 times 2 times 2 times 2. Then I have 1 3. I have 2 b's and 3 c's. So we multiply all that together. So our least common multiple is going to be 96b squared c cubed. There is our least common multiple. Now, you don't have to write out your letters if we understand that we are just going to take the most that occur often, or we're going to take the most often. Jumping to 9. Now with 9, when we're given more than one term, this is one term, this is 3 terms, we have to factor it. So let's see if we can factor this. Remember, when we factor, what multiplies up to there adds up to -3. That is going to be x minus 7 and x plus 4, because -7 times 4 is -28, add up to a -3. This guy factors to x minus 7 and x minus 1. So now when we have factors like this, we have to take all of our factors that occur. So I have this guy, which is x plus 4. I also need this guy, which is x minus 1. Written like this, now we can just take one of these because they are in both of them, right? So I don't need to write both of them down. I just need to write one of them down. So it's going to be x minus 7. So my common denominator is going to be right here. Now I know it looks tempting to multiply this out, but please don't multiply it out. Keep it as is. It will help us later on for simplifying, and it's just going to save you a lot less hassle. Here with 10, what do we have to do? We have to factor. Well, what does x squared minus 2x minus 8 factor into? That's going to factor into x minus 4 and x plus 2, because they multiply to -8, add up to a -2. Then here we multiply, or we factor, so we get x minus 7 and x plus 2. So what factors are not alike? We have x minus 4 and x minus 7. X minus 4 and x minus 7. Now we have factors in both expressions. So now I'm just going to take one of those because it's in both. It's just going to be x plus 2. And now we have our common denominator again, where it's just these. And again, please leave it like this, because when you multiply it all out, it gets to be a headache. But that does it for section 11.6, adding and subtracting rational expressions, part 1. Good day.